Hello and welcome. This is Michael Annis, and you're listening to episode 15 of the Space Rocket History Podcast. And now, Sputnik 3 and Luna 1. On January 1st, 1958, work began in the Soviet Union on designing the vehicle that would become the piloted Vostok and the recoverable Zenit photoreconnaissance satellite. The Vostok program would soon put a man in orbit for the first time. Vostok was a classified word before the release of the program's name to the press. Now let's move on to April 1958. The twice postponed Object D satellite was finally ready for launch. You may recall from episode 9, Object D was planned to be the first satellite launched by the Soviet Union, but due to problems developing the extensive scientific experiments and their telemetry system, the launch was delayed in favor of the much smaller, simpler satellite called PS-1 or Sputnik 1. Design on Object D had begun in January 1956. It was conceived as a multifunctional science laboratory with an ambitious array of instruments on board. It also promised practical experience, which could later help in the development of attitude control systems for future spacecraft. Object D would also provide engineering data on the thermal conditions inside the satellite, the interaction of the satellite with the upper atmosphere, and the satellite's movement relative to the center of gravity. Object D was shaped like a cone. To me, it resembled a Dalek from Doctor Who. It was 3.57 meters long and 1.73 meters wide at the base. It weighed 1,327 kilograms. It was 3 times heavier than Sputnik 2, 95 times heavier than Explorer 1, and 902 times heavier than Vanguard 1. When Object D was finally completed, it had 12 scientific instruments on board. They were used to provide data on pressure and composition of the upper atmosphere, concentration of charged particles, photons, in cosmic rays, heavy nuclei in cosmic rays, magnetic and electrostatic fields, and meteoric particles. A tape recorder was included to record data when the satellite was out of range of a ground station. Object D was launched on April 27th from the Baikonur Cosmodrome by a R-7 rocket. Unfortunately, the launch failed when the launch vehicle disintegrated 88 seconds into the mission. This is how Oleg Ivanovsky, who worked on Sputnik 1, 2, and 3, described the failed launch. Quote, "We had our first space failure. It was April 27, 1958, and it was caused by a rocket engine failure. The rocket went up about 12 to 15 kilometers, and the satellite fell separately. There was a search for the satellite. I remember that. The pilots conducting the search were not allowed to know what they were looking for. Just search the area for anything unusual, they were told, and don't attract the camels. It was crazy secrecy. Finally, one pilot came back and said he had seen something that sounded to us like the satellite. We sent out a rescue team in an armored vehicle. When we got back, some of the instruments could still operate." End quote. As chief designer Korolev prepared to make another attempt, he learned that the onboard tape recorder was not working. The tape recorder function was to accumulate data from the different instruments and to prepare messages for the ground station. It was necessary to have a tape recorder because the spacecraft revolving around the globe would only be in contact with the ground station during periods of direct radio visibility. Simply speaking, the ground station would be unable to sense the signals from the spacecraft when it was behind the horizon. With such a crucial role, members of the scientific team were extremely worried about the troubled tape recorder, and they recommended postponing the actual launch to give the technicians a chance to fix it. However, the tape recorder's ambitious engineer, Alexei Bogomolov did not want to be considered a loser in the company of winners. He suggested that the testing failure was simply caused by electromagnetic interference from all of the different electrical circuits in the test room. He boldly proposed to launch Sputnik 3 on time. Still, Korolev planned to delay the next launch until the problem was fixed. But he received a phone call from Premier Khrushchev himself. Khrushchev told Korolev that Italy was about to hold national elections. Its Communist Party was strong, and Khrushchev believed that a successful flight of the new Sputnik would swing millions of votes. He ordered Korolev to launch immediately. On May 15th, Sputnik 3, the backup of Korolev's Object D satellite, launched from the Baikonur Cosmodrome by another R-7 rocket. Here's an audio clip of the launch.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Зажигание. Старт. Пуск.
Sputnik 3 went into a 216 by 1,863 kilometer orbit. Unfortunately, to the great embarrassment of the Soviets, the huge vehicle missed one more chance at what would have been its most significant achievement, which was mapping the Earth's radiation belts. United States Explorer 1 satellite, which had revealed the existence of the radiation from the belts, had at first been overwhelmed by its intensity, and it took some time for the Van Allen analysis team to understand what it had measured. Sputnik 3 could have mapped the belts systematically, but failed to do so because of, you guessed it, a defective tape recorder. The most disappointed Soviet scientist was Sergei Vernov, a renowned physicist. The detectors on Sputnik 3 sensed extremely high levels of radiation, but was it local or did it exist around the Earth? Some 6 weeks earlier, on March 26, the U.S. had launched Explorer 3, which carried the first tape recorder ever launched on a satellite. The recorder gave the Explorer 3 team complete orbital coverage of radiation intensity data. The Soviets, without tape-recorded data, were seriously hampered. This eventually led to a scientific controversy. Vernov published a photo of what is now known as the Van Allen belts in Pravda on March 6, 1959. He alleged that the data was based on findings that he had reported at an International Geophysical Year conference in August of 1958. However, colleagues of Van Allen, who heard Vernov's presentation in August of 1958, maintained that the fragmentary data available at that time from Sputniks 1, 2, and 3 could not have possibly formed the basis for such a finding, and what's more, no such finding was reported by Vernov at the conference. Afterwards, a Russian joke circulated that the belts were to be called the Van Allen-Vernov radiation belts. What did Vernov do? He discovered the Van Allen belts. Here is a 1958 news clip for Sputnik 3.
The 12-foot-high Sputnik 3 weighs 1.5 tons, 3 times heavier than the dog-carrying Sputnik 2, 100 times heavier than the largest of America's 3 satellites. It's an impressive indication of Russia's major strides in science and industry, played up for all it's worth by the Kremlin as a red victory in the battle for world prestige.
While Sputnik 3 had little impact on the Italian election, it certainly made heads turn. The weight of 2,925 pounds removed any doubt that the Russians would soon have the capability to send an ICBM to the U.S. At a Soviet-Arab friendship meeting in the Kremlin, Premier Khrushchev told his guests that America would need, quote, very many satellites the size of oranges in order to catch up with the Soviet Union, end quote. Now let's move on to Luna 1. On January 28, 1958, Soviet chief designer Korolev proposed a program of lunar exploration missions, including impact on the moon and photographing its surface. There were 4 launches of the Soviet lunar impact probes, sometimes referred to as the Lunar E1 series. They were called Luna E1 number 1, E1 number 2, E1 number 3, and E1 number 4. All 4 of the Luna E1 spacecrafts were virtually identical. They weighed 361 kilograms and were spear-shaped. 5 antennae extended from one hemisphere. Instrument ports also protruded from the surface of the sphere. There were no propulsion systems on the spacecraft itself. Luna 1 contained radio equipment, a tracking transmitter, and telemetry metering system, 5 different sets of scientific devices for studying interplanetary space, including a magnetometer, Geiger counter, scintillation counter, and micrometeorite detector, 1 kilogram of sodium. We'll explain the sodium in a minute. The spacecraft also included various metallic emblems with the Soviet coat of arms. The launch vehicle for the Luna E1 series was a modified R-7 named Vostok. The Vostok had 3 stages. The first and the second stage were the standard R-7, which we covered in episode 9. A 5.1 meter long by 2.4 meter diameter third stage was added to the top of the R-7. The third stage weighed 1,472 kilograms and was capable of delivering 54.5 kilonewtons or 12,252 pounds of thrust. This was the probe's booster stage that gave it enough speed to escape Earth's gravity. Korolev knew that the U.S. was planning to launch a lunar probe on August 17th. He faced considerable pressure getting the Luna and its booster ready for launch. Despite a number of technical issues, the pad crews managed to get the booster ready on August 17th, but Korolev instead decided to let the U.S. flight go first on the reasoning that the Luna probe had a shorter trajectory to travel and would reach the moon first. After the U.S. Pioneer 0 launch ended in a booster explosion, Korolev decided to postpone the Luna E1 number 1 flight due to some problems found with the third stage booster. By September 23rd, Korolev believed the booster problem was solved and gave permission to launch E1 number 1 on a mission to hit the moon by way of direct ascent trajectory. However, the booster failed and disintegrated after 92 seconds. In addition to the booster problem, Korolev was faced with a launch window limitation. There were only a few days each month when the moon was in the best position for a mission. The next window would come on October 11th. This date coincided with the U.S. launch of Pioneer 1. For a minute, it seemed that the moon race would turn into a real race, with both the U.S. and Soviet Union launching on the same day. After Korolev heard of the successful U.S. launch, he asked his crew to shake off sleepiness and fatigue, drink some strong tea, and continue to work. He told them, quote, "Don't worry that the American rocket is already flying to the moon. We will reach the moon several hours before the Americans," end quote. The Soviets did manage to launch E1 number 2 on October 11th. But once again, the booster exploded 104 seconds after liftoff. And you may recall from episode 14 that Pioneer 1 failed as well. Obviously, the addition of the upper stage to the basic R-7 had rendered it unfit for flight. Korolev instructed his chief ballistics officer, Svet Lavrov, to find and fix the problem. Lavrov eventually found that the problem was due to powerful oscillations within the liquid oxygen lines, which had torn the rocket apart. Lavrov used dampening devices in the oxygen lines to make the fix. On December 4th, Luna E-1 number 3 was launched from the Baikonur Cosmodrome. However, a new problem occurred. The core stage rocket engine shut down after 245 seconds because a hydrogen peroxide pump had seized up due to loss of lubrication. This failure was totally unrelated to the liquid oxygen line oscillations problem. Finally, on January 2, 1959, Luna E-1 number 4 was successfully launched on a mission to hit the moon by way of direct descent trajectory. This time, the rocket, including the upper stage, performed flawlessly. Soon, E-1 number 4 became the first man-made object to reach escape velocity of the Earth. At a distance of 13,000 kilometers from Earth, E-1 number 4 released its 1 kilogram of sodium gas. It made a glowing orange trail of gas with the brightness of a 6th magnitude star. This allowed astronomers to track the spacecraft. It also served as an experiment on the behavior of gas in outer space. Later in the flight, it was discovered that a malfunction in the ground-based control system caused an error in the rocket's burn time, which made the spacecraft miss impacting on the moon. Instead, it flew by the moon at a distance of 5,900 kilometers. Thus, E-1 number 4 became the first spacecraft to reach the vicinity of the moon, the first instance of a radio communication at the 500,000 kilometer distance, and the first man-made object to reach heliocentric orbit. As a result, the Soviets declared E-1 number 4 a new planet and renamed it Mechta, which means dream. Mechta's orbit lies between the Earth and Mars. The name Luna 1 was applied retroactively years later. Luna 1 was also referred to as the first cosmic rocket, in reference to its achievement of escape velocity. The measurements obtained during the mission provided new data on Earth's radiation belt and outer space, including the discovery that the moon had no magnetic field and that solar wind, a strong flow of ionized plasma emanating from the sun, streamed through interplanetary space. Korolev was disappointed about the outcome of the mission because the probe failed to hit the moon. Moscow, however, was very pleased with the outcome. Once again, everyone declared that Korolev had scored a major success because he built the first rocket to achieve escape velocity, pass very closely to the moon, and then go into orbit around the sun. Once again, the United States had been beaten. To Washington, the success of Luna 1 demonstrated again the lifting power of the R-7 missile. A U.S. Congressional committee declared that, quote, inexorable changes in society and political power will follow the development of space capabilities. Failure to take account of them would virtually be to choose the party of national extinction, end quote. Time magazine called it a race that may decide whether freedom has any future. Thanks for listening to this archive episode of the Space Rocket History Podcast. If you are financially able, please support the podcast by going to the homepage, spacerockethistory.com, and clicking on the orange donate button or the Patreon link. Thanks.